and welcome back to the Towards Data Science podcast. Now, imagine for a minute that you're running a profitable business, and part of your sales strategy is to send the occasional mass email to people who've signed up to be on your mailing list. Now, for a while, this approach leads to a reliable flow of new sales, but then one day, that abruptly stops. What happened? You pore over logs looking for an explanation, but it turns out the problem wasn't with your software, it was with your data. Maybe the new intern accidentally added a character to every email address in the dataset, or shuffled the names on the mailing list so that Christina got a message addressed to John, or vice versa. Versions of this story happen surprisingly often, and when they happen, the cost can be huge: lost revenue, disappointed customers, or even worse, an irreversible loss of trust. Today, entire products are being built on top of datasets that aren't being monitored properly for critical failures, and an increasing number of those products are operating in high-stakes situations. That's why data observability is so important, the practice of tracking the origins, transformations, and characteristics of mission-critical data to detect problems before they lead to downstream harms. And it's also why today I'll be talking to Kevin Hu, the co-founder and CEO of Metaplane. Now, Metaplane is one of the world's very first data observability startups, and Kevin has a very deep understanding of data pipelines and the problems that can pop up if they aren't properly monitored. And he joined me to talk about data observability, why it matters, and how it might just be connected to responsible AI on this episode of the Towards Data Science podcast. I think you're working on a problem that's, I think, so much more important than the average data scientist who just focuses on model building all day might realize. Although if they're in an enterprise setting, I think quickly they're forced to realize that it's important. So we'll be talking a lot about data observability among other concepts today. I think data observability is going to be a new thing for a lot of people. So maybe we should just start with that. What is data observability?
Well, it is a big concept, and it borrows from software observability. So you have companies like Datadog and SignalFX that have concepts like metrics, traces, and logs. And the idea is with these three ingredients, you can reconstruct the state of a software system at any point in time. And data observability kind of borrows from that concept, saying what information do we need to be able to reconstruct the state of our data systems at any point in time. And it goes all the way back to control theory, which is the origins of the observability term. And it has a very interesting history there too.
So what is the history in the context of control theory? Because I don't know, I hear control theory, I get excited. I'm one of those people.
Okay, so the history, let me see if I remember correctly. James Clerk Maxwell actually invented it, right? The Maxwell equations guy.
From physics.
From physics. And he used it to describe, what's it called? A centrifugal governor. It's like a device. It kind of looks like a person, but with your arm stuck out to the side, and you're attached to a steam engine. And as the steam engine rotates, you're almost like an ice skater, right? You have two heavy spheres at the end of two arms, and as you increase the speed, the spheres go out more, which kind of slows down the engine. And as you decrease the speed, you're pulling the arms a little bit. So it tries to keep the speed within a certain range. And believe it or not, this was actually discovered by Christian Huygens, the astronomer, the same astronomer who discovered Saturn's rings and invented the pendulum. These old scientists were crazy, right?
I knew my physics degree would place me among useful people at some point.
Yeah, I mean, it goes so far back. The idea is James Clerk Maxwell said, okay, how do we actually formalize this system as a set of linear equations, right? So that's where control theory came about, trying to say, okay, if we have this system that's described with a state space representation with a bunch of equations, how can we control the inputs to control the trajectory of the system? And that's the idea of controllability is kind of one-to-one with the idea of observability, which is given that we know the outputs and the trajectory of the system, how can we back up the inputs? And there's a very formal definition in control theory, which is you have a system of equations, you turn it into a linear algebra problem. If it's full rank, it's observable. If it's not, then you have some degeneracy in there. But uh, when we bring it to today, right, software observability borrowed pretty like liberally from that concept, saying like
Yeah.
roughly what do we need to know to understand the state of the software system? And data observability does the same thing for data systems.
What goes into the state of a software system? So there are people who are listening who are more on the software side, so they can go, oh, okay, like I see the analogy here.
Uh, they describe it as like three pillars. Metrics. So like, for example, what is the CPU of this EC2 box somewhere? Traces. So like, what are all the different interactions and the state of the system and how are they related to each other at a point in time? And logs, right? Like literally every piece of information that's being output by the system. And the idea is like when you combine the three of those, you can really understand like, okay, aha, like 1 week ago, this is how my box was behaving, right? It was uh, really going overboard with memory usage, the disk was full, etc.
Okay, so essentially it's like, in theory, it gives you a complete picture of what your entire system is doing at any given time. That's sort of the goal here with software. How does that change now with data? I mean, this is obviously, there's a data set now, there are models, there's a whole ecosystem. So how do you have to modify that paradigm?
It takes me back to I had a computer science professor that would say, things are exactly the same but completely different. And the data world, like there are some similarities, right? Of course, like we use software to generate a lot of the data, to model it and transform it. But there are some critical differences. And to give you an example, like data has lineage, right? The output prediction of this model, you can trace it back to this feature in a feature store. You can trace it back to a
Right.
data warehouse, to all the way back to like a user interaction. That's kind of a novel concept in software. You do have infrastructure dependency mapping, but it's a little bit different. And there's a couple of other differences as well.
Okay, so the existence of a data set, I guess, can be modified as well, transformed in different ways. So I guess you have to track that in some way. What are some of the mechanisms that might go into that?
This concept is called lineage or provenance within data systems. Like, okay, given this data point, like where did it come from,
Yeah.
right? What are the operations that were, enacted on it to get to this point? And lineage is a very, very difficult problem, but it really lies at the heart of uh, one critical piece of observability. Like in data observability, uh, we like to think that there are like four key components. Uh, Two of them are trying to describe, okay, like what is the data, right? Like the data itself. Data has statistical characteristics. It has some degree of like nullness and completeness. We like to think of those as like internal metrics.
Okay.
Data also has like external characteristics. Like when was the last time the data was refreshed? How many rows are there? What's the structure? That's like the metadata.
How would you describe the difference between internal and external characteristics of a data set?
I would describe it as kind of like in thermodynamics, right?
Okay.
Where you have like intrinsic properties of a system, like the temperature or the entropy of like, let's say like a cup of water. And you can have like 5 cups of water. You can add more and more water, but the temperature can be the same.
Right. So independent of the quantity or the amount of data.
Exactly. And same thing with data where the statistical properties of this column can be preserved even as you double the size of the data set or add another column or refresh it.
Okay, so something like the mean or the standard deviation of a particular column is something that theoretically, I guess, because when you add more data in practice, it will change, but theoretically, it could remain in a counterfactual world. It could remain the exact same. So that's sort of the philosophy between those two.
That is the philosophy. You're right. Like there's theory and there's practice, right? And
Okay.
you're right. Like in theory, the two are very deeply related, but you can disentangle them, kind of in the limit case.
Okay. Okay, great. So we've got things that are analogs for, like, let's say the mass of the data set, things that are analogs for the temperature of the data set. So intrinsic and extrinsic, or actually extrinsic and intrinsic in that order. Okay, so what are those the some of the other pillars? You mentioned there are four.
For sure. I mean, those two pillars, right, the internal, external, are kind of describing the data set itself. But then you think about, okay, what are the interactions that happen within the data world? two of the main interactions are, right, lineage. So data interacts with other data. For example, one table in your Snowflake warehouse is the result of joining two other tables. It's a simple example, right? So you have the lineage between those two, and you also have the interactions between the data and the external world, so to speak.
Yeah.
Right. Like this is a software, like a Salesforce data source, and it's being replicated into my warehouse, right? What is that replication? Or like the data is being used by some executive who's looking at a sales forecasting dashboard or an end user who's interacting with your prediction. So you have the machine to machine, and then you have the machine to human interactions. And we like to think of those as captured in logs.
Okay. Both of these, sorry, yeah, the lineage and then logs are the two other. Okay, I see. And so in terms of like these things sound like they'd be very challenging for a lot of companies today to actually put into practice. I'm thinking especially when you talk about lineage, actually lineage and logs, they both kind of play into this. But like, let's say a typical data set that I might collect by scraping, let's say a whole bunch of information. Then I clean it and I remove a bunch of, so like my entire data pre-processing pipeline essentially has to be recorded somehow. Or like, how does that get done in practice? And I'm guessing there are a lot of different levels of maturity on that, right?
There are. In practice, it doesn't get done.
Okay.
For the majority of companies, like you're suggesting, it's very challenging. I would say the software world is maybe a couple years, maybe upwards to a decade ahead of the data world. And the systems just really don't exist for us in the data world to capture that kind of metadata in an easy way without a lot of manual annotation, where you literally walk through every transformation step, trace out the lineage yourself, and it goes out of date the next week, the moment someone else
Right.
adds a transformation. It's hard.
Because yeah, I imagine like I'm trying to think of the software analog for that. Because you have people who build software, you don't tend to. I mean, you do have to work logging into your workflow, but it doesn't tend to be this thing that weighs you down that much. Like what I don't know. What are your thoughts on that mapping? Like, what is it that makes data so difficult to log, and what are some of the solutions that might help?
Uh, I think the software world is like that today, but I don't think it's always been that way. Even if you rewind the clock like 10 years building software, I remember this. It's like, okay, you have a Rails app, you push it to an EC2 box, have a heartbeat check, kind of
Yeah,
call it
yeah.
a day. You remember how it was. Today, if you like spin up your Kubernetes cluster and don't have Datadog, it's like, what are you? That's the first thing you do. Uh, and in the data world, I would argue the tools just really don't exist for this kind of observability, which is kind of why we're working in this space. But also, the need hasn't always been there, and that the need for data observability is only increasing over time as data is kind of shifting from having one vein within organizations, which is reporting in business intelligence dashboard, which is important, but if it goes down for a day, it's not the end of the world. Two, frequently being used in like real-time machine learning models. Every second that that is down or incorrect, that there are consequences there. And now that the stakes are higher, we like to think of it as data becoming a product that's used across use cases. Now that the stakes are higher, you kind of have to get your stuff together.
Yeah. Yeah, no, that makes perfect sense. And you know, even in the context of models, like it's not just going to be one model that rests on this data set. It's like many different models with potentially interdependencies and like a whole bunch of different use cases that come to depend on them. Increasingly, in fact, like what I find really interesting about this is there seems to be an interaction too with the state of machine learning tech, because we're also seeing an era of foundation models where you have these really huge models like GPT-3 and others that have a whole bunch of different use cases, and they're all trained on very similar data as well. So it's sort of like you have these kind of stacked risks that if you're not kind of paying attention to every stage, that risk compounds.
That is a great example. I think ML and AI ops is like a whole nother world, very adjacent to the data ops world, where, like you're saying, like the complexity can really explode when you're dealing with like these foundation models, where you have your own like fine tuning on top of that. You have
Right.
some domain customization and user interaction, and all of a sudden it's like, oh, we have nowhere to begin when it comes to understanding how like intricately how this model is working for our end users.
And so, in terms of like actual kind of problems that can arise if you're not covering your bases on this stuff, I'd love to get some, because I think you're familiar with enterprise level data stuff. I think a lot of our listeners, some will be on the enterprise side, but some will be at sort of small startups with smaller data sets. So kind of a range of people. What are some of the problems that arise maybe in different contexts at different scales when you don't actually pay attention to the provenance of your data or the logging or things like that?
Highly vertical dependent, we found, where we mentioned before, like software and data are like these two tracks that are eating the world, right? Software is a
Yeah.
little bit ahead, data is catching up a little bit, and adoption of like the modern data stack uh, is, we've seen it kind of most in industries where data is directly tied to the success of the business, whether it's like financial services or healthcare settings or e-commerce. Even like every second that the data is incorrect,
Yeah.
it has an effect. Um, and the kinds of things that can go wrong are, there's a whole mountain of them. It really depends on the complexity of the system. You can have, for example, external dependencies. You're pulling data from, let's say you're an e-commerce shop, you're pulling data from Shopify, you're pulling like growth marketing data. And someone can do some data entry incorrect. They enter in the wrong currency. And one number is suddenly 100 times higher than expected. That can really, really skew your downstream model. Such an innocuous difference can have a big impact. And there's tons of different transformations along the way where you introduce more and more points of failure, and they all interact with each other. That's the problem.
So how do you debug that today? Like if you have a great setup, something goes wrong in your I mean, I guess the problems could manifest in many different ways. You'd see maybe a sudden crash in um, model output or a change in the distribution of model output, something like that. And then you go, okay, where's this coming from? Models maybe being retrained on the fly on a data set. How would you trace that back?
So in terms of the consequence, I think like the model is like one
Right.
example of a consequence. It's a very important one and relevant to this conversation, but in many cases, many companies don't even have
Right. Yeah.
machine learning models trained on their data. They might have business intelligence dashboards, executives making an incorrect decision based on forecasting data. You can have the data being fed back into these systems using reverse ETL tools. So suddenly you send out a marketing campaign where you include the wrong name for everyone.
Right.
Uh, this happens quite a bit. And when it does happen, I kid you not, and like this matters because the moment you've received like, you know, someone says, you know, hey, what's a good name? Hey, Jack, right? Make sure to log into Netflix again. It's like, who are you, right? Get your
Yeah.
data together.
And it speaks to
And
trust too.
trust is, I would say, the one of the biggest problems that we're trying to solve. Any observability tool where it always comes back to the humans, right? Trust is so easy to lose and very hard to regain. And the process for doing that, like you're suggesting, is not very well formed in the data world. The software world has its whole like own instant response playbook. There's crazy acronyms like PICKERL, where you like prepare, identify. You have a whole pipeline that you go through. In the data world, it's very hard to kind of even know where to start.
Is like what's the state of development on that line of thinking? Like are people actually making progress? Like you mentioned about we're about 10 years behind. So if I'm thinking back accurately, yeah, like 2011 was not a great time to be in software engineering.
Yeah, that's true.
What are some of the key areas where you think people are making progress towards kind of verifying data set status and health and all that stuff?
I think some of the large storied companies are making progress where Airbnb and Netflix, Meta have entire data observability internal tools and teams dedicated to building these tools. But of course, uh, Netflix has more people on its data platform team supporting data scientists than other companies have employees,
Yeah.
right? Um, and that's where like the off-the-shelf software comes into play, and that is extremely, extremely young. Like the age of all of these companies, you can probably count them on one hand, using the fingers on one hand.
Is speaking more about this interaction between data and machine learning. Um, all kinds of different possibilities for adversarial attacks against machine learning models. I shouldn't say, sorry, not adversarial attacks in the sense of adversarial learning. I just mean kind of malicious attacks against data sets. Like one common one is, or commonly talked about one, is data poisoning, where you actually kind of inject malicious data. Like, can that be monitored for today? Are there strategies that can help mitigate that through good data ops?
ML ops is not my area of expertise, but I do have a couple of opinions here. One is, it comes back to observability again, where like, what are you measuring in this system, right? If you're measuring only the key model metrics, like the F1 score, it's tough to capture the few data points for which you have a very negative prediction, negative as defined by like the outcome for your business. And some people will say, okay, we just have to develop better models, build more robust and resilient models that can handle these kinds of adversarial attacks. And while that's true, we can't just like sit here and loiter while people figure out better models in the ivory tower, right? Like we know that in practice, developing models and knowing like the data that is being input to the model, like it's a very intricate relationship, right? Mm-hmm. We fine tune some parameters, change the architecture, look at the data samples, and understand like the lineage of, okay, where did that data come from? What was the prediction for this one data point, and the interplay between the two. The second part of understanding the data lineage, I would say, is a little bit underdeveloped right now, at least speaking from the data ops world. Yeah. But I hope that we can get there.
Yeah, I mean, it would be great to see more of that. On the metrics side, I imagine like, is some of the work on looking at a data set and analyzing it from a metric standpoint algorithmic, where you go, okay, like anomaly detection or something like that?
I think a lot of it is algorithmic, and how generic it is depends on like the company. So like at the end of the day, when all of the data is being like pushed through the pipes and transformed, and you have like this nice set of metrics that you're trying to understand, that is very business dependent, and every business is unique in that way, right? Something as simple like how do you calculate churn can vary a lot between companies. So I think anomaly detection at that layer has to be complemented by a human in the loop with domain expertise. Because it's like, okay, this generic model does not know more than your CFO. But kind of upstream of that, I think anomaly detection plays a much bigger role, where whether you sell socks or you are selling online teaching courses, if you store your data in Snowflake and we see 100 new rows every day and suddenly we get 0, that's a problem.
Right. So fairly naive strategies can go a long way. I mean, I guess most of the problems are usually pretty obvious when there's something like infrastructure-wise that's wrong. Like you just get a sharp drop in something. So you talked earlier about this idea that you have dashboarding and sort of models being built from the same data set. Does this imply that you can't come up with a one-size-fits-all solution for this stuff? Or are there ways to kind of accommodate, because the needs of a dashboarder and from a reliability standpoint and data integrity standpoint seem like they'd be different from the needs of a an ML ops or a machine learning kind of downstream model?
As much as I want to say that the dashboarding use case is less important or less like critical to fix, the fact is that in many cases it does have a real impact. Like the moment the CFO is like, shoot, I reported to my board this number that turned out to be incorrect, like that really does have an impact. But in both cases, even though the time to identification matters less for the dashboarding case, in many cases, in the data world, data issues compound, right? It's often not like one value is wrong. It's so isolated. It's like one value was wrong. It propagated to a whole bunch of different tables and a whole bunch of different dashboards. And every day that passes, you keep adding more and more data. So when you do resolve it, it's almost like an exponential function of how much time has passed. So I would say like time to resolution matters in both the real time and the batch cases. Because if you wait too long, good luck trying to backfill all that data. Like it no longer exists.
but you built a company around addressing a lot of these challenges. I'm curious from your perspective at Metaplane, like what are some of the low-hanging fruit that you've decided to tackle first? What are some of the kind of most valuable problems that are tractable today in this area?
One of the most common problems is like a data freshness issue, right? Where data that you expect to be updated every hour, actually, it's been a day. And oftentimes today, data teams honestly don't know when data is delayed. And we find that it's like super ironic that, as data people, right, it's our job to help other people feel more confident about making decisions. But what about us? What kind of data do we have to make our own decisions? And the answer is like not very much. So we try and like go after the low-hanging fruit first. Where it's, okay, make sure that your data is fresh. Make sure that it has the volumes you expect. Make sure that this field that you expect, which is unique, actually is unique. And we kind of like go down the long tail and make a really easy way for your team to say, okay, plug in Metaplane to my Snowflake and maybe my Looker and DBT, and just like track these characteristics for me. And when there is an anomaly, tell me what's the downstream impact, what is the upstream root cause potentially.
And then where does this all go? Like, what do you see the vision of the product going? I'm using this kind of as a proxy for, what does data ops look like really 5 years down the road? Like, how do you see that developing?
That's a good question, right? Like 5 years down the road, it's hard to even predict what technologies will be around, right? SQL, probably. SQL has survived long enough, Lindy effect, right?
Yeah.
Even like the database is hard to say if they'll still be around in 5 years the way that we know them. What we hope is that every data team will be able to trust their data and assure their business users and the end users that the data is trusted. And if there is an error, that they are the first to know.
That makes a lot of sense. I think that this is like weirdly entangled with, we've had a lot of conversations with kind of AI policy people on the podcast. And there's a lot of talk, obviously, about reliable AI, bias in AI, this sort of thing. And I can't help but think that, like, okay, all the principles in the world are great, but we seem to just lack a fundamental ability to have the rubber meet the road and actually measure these things in real time. So, you could say that you need to refresh your data this often, or you need to make sure that your model is not being kind of put into production out of distribution, whereas it was trained on something else. But what mechanisms exist for you to actually assure this? It seems like we're missing kind of an entire part of that value chain.
100%. And like the little breadcrumbs just don't exist, right? I would say, a software observability tool like Datadog, if I were to really approach it with a reductionist lens, is just a metadata collector, right? Whether it's useful or not, here's a log on this ephemeral machine 3 weeks ago. Maybe down the line you might need it. That kind of breadcrumb collecting doesn't really exist in our world, right? Like, pop me into a random data team, and if you ask the question, was this dashboard up 1 month ago? I don't know.
Yeah.
But they should know, because that data was produced at a certain point. It wasn't collected and aggregated in a way that they can retrieve.
Yeah, it's almost like every Excel spreadsheet is like a product failure.
That's quotable right there. Put it on a mug, I'll buy
it. There we go. Anyway, no, I mean, I do think it's really interesting because, like, again, I think it's from a machine learning standpoint, it's part of the safety story here, and there's so much that needs to be done in terms of trust building, both with companies and governments, and even governments to governments. Like, you don't want a situation where, to draw the analogy with like nuclear weapons, even, you need assurance that your counterparty isn't doing something risky and they're actually following whatever agreements you've set out. Otherwise, the agreements have no force. This seems like it is really part of that ecosystem.
For sure, yeah. And to go even deeper in that, like, ideally you have like a rock solid, like, assurance, and not just relying on game theory and mutually assured destruction, which tends to work, but you only need it to not work once, and that's it. That's humanity.
Well, and I do think when it comes to AI, like it's an especially thorny problem because like the nice thing about nukes is like it's clear when they've been launched and they don't tend to get launched accidentally. Whereas with AI systems, like you could go like, oh well, we misspecified the objective or there was an error in training. That's why we just launched these automated weapons at you. It's not really that we wanted to do it. So you kind of get into this murky middle ground where without assurance, without being able to show that actually we are implementing these best practices, you don't know whether to attribute something to an accident or to malicious use. And that I think is like where visibility, observability rather, is just so important in this whole process.
I really, really like that analogy. And kind of like the amount of information that we have really impacts like where do we assign responsibility, right? And oftentimes like nowadays there's still like this mystical aspect
Yeah.
of like AI responsibility, like oh like the neural network decided it. I'm like, who made the neural network, right? It's linear algebra, but the fact that we don't have like a detailed understanding, which stems from like detailed metadata, is yeah, you're right, really impacts the way we behave towards these models.
Do you think this could be true of companies too? Because like I imagine, we live in a world of data leaks, data breaches, all kinds of, we don't need to recite all the usual scandals, but there have been quite a few. It just sort of seems like a company that isn't tracking their data health in this way is it's almost exposing itself to a certain degree of risk just reputationally.
That's definitely true, especially when the data is being used by the end users. And that there's no buffer of, this data is being used internally. That as data is becoming a product, being more and more used by end users, like the risk only increases.
It's almost like if I was an insurance company, I would want to require that the company I was insuring actually had some mechanism to track this kind of thing, which makes it seem so crazy that we're not there yet, that this infrastructure doesn't exist. Um, do you think that's just the stage that we're at? Like, is it a reflection of the fact that people haven't realized that this is a problem, or is it that the solutions are so technically hard to develop that that's kind of the main delay?
Now, people are busy. Data teams have so much on their plates. I have so much sympathy for every data engineer and data scientist out there, where like even just getting the data into place to do something productive with it it's a lift,
Yeah.
right? I mean, and to be able to implement observability into your system, like that's very tip top of Maslow's hierarchy, the way that it is structured today. Uh, you know, but there are a couple of different reasons I would say it's taken a while for data observability to take off as a concept. Like for one thing, it's not a new concept. Decades old, data integrity and quality were in some of the original like database papers by
Mm.
Cod himself. The reason it's like possible now is, of course, Big Daddy Moore's law, right? It's the price of compute. It's possible to make data warehouses like Snowflake, where you can infinitely scale compute independent of storage, and suddenly you have this unit of compute that's dedicated to observability that doesn't impact everyone else.
Oh, that's okay. This is actually really interesting because I think there's a connection to some weird cutting edge AI stuff that I just did a podcast with Yang Gao, who's one of the authors of this Efficient Zero reinforcement learning paper. This is going to sound totally unrelated, but I
No,
swear there's a connection. So one of the things with Efficient Zero and Mu Zero and some of the cutting edge RL things is that they're much more data efficient because what they do is that for each sample of sort of like experience they get playing a game, they'll invest a ton of compute in terms of kind of modeling out like what would I have done if the sample were not a little different, but like what could I have done in response to this? What would that response have led to? And like just the abundance of compute means you can squeeze so much more out of every data point. And you actually see this reflected in sample efficiency, where for a couple of samples, these things learn a lot more than they used to. This kind of seems like the analog to that. Like you say, Moore's law makes it possible, economically viable, to like start to invest a lot of this compute into looking at the data itself without actually training a model on it.
when you just described that, it makes me think, not to make light of it a little bit, like an operationalization of anxiety. Like
Yeah.
like as a human, like we're constantly, okay, what if I did something else? What if I, or like what if I do this? What could go wrong?
Yeah.
Whereas, like if you walk a dog along the street and they see another dog Like for 1 second, they'll be like, I'll kill you, right? Like, get out of my face. And then the next second, they just don't think about it anymore. Whereas we have like this lingering mental model.
Yeah, all that excess capacity. Yeah.
It's just like, yeah, it's, doing something.
Yeah, I mean, evolution has kind of wired us for like Malthusian states where we're just like we don't have enough economic surplus to like have spare RAM cycles, and now all of a sudden we do. We have like all this spare time, and we end up freaking ourselves out about everything.
Exactly. I mean, I think like I think you're exactly right. Like, how are we wired to operate under this surplus world, right? Like you can see even like physiologically, people, in this caloric surplus world, we have, eating is easy, right? Of course, you want candy. Of course, you want this oily food. We're like the one generation out of like 100,000 years of evolution that has to face that trade-off.
At least we have better data observability tools now, so that's okay.
Yeah, exactly. It's hopefully at least we'll have that, and we can keep eating our candy along the side. But you're right. Like the abundance of compute has totally made it possible just in the past few years, actually.
And that's also kind of made teams like data teams more, you use this word in your own post, actually I kind of liked it, data teams more entropic. There's like a lot more different roles in data than in software engineering. Would you mind kind of unpacking that and like looking at how that interacts with the data ops side of things? Like what the fact that we have all these different roles, we have the data analysts, we have the data engineers and the ML engineers and so on, like what impact does that have on data ops and how you think about it?
Yeah, it's funny you picked that out. The idea of entropy in a system being a measure of kind of its information content or predictability, right? Like highly entropic systems, you have this box of gas and it's super everywhere, and you need to have a lot of information to describe that state. And as a result, you can think of it as like the number of questions you need to ask in order to really understand this. It's like playing a game of 20 questions, right?
Yeah.
If I think of something random, like, I don't know, like the couch in Seinfeld or the Canadian arm of the ISS, right? You're gonna have to ask a lot of questions to get to that point. And for data teams, let's contrast this for a second. Software teams, I would argue, are quite predictable, right? Give me a 1-person team, right? I will predict it's a full stack engineer. Give me a 10-person team. I'll predict there's a mix of front-end engineering, back-end engineering, maybe infra and SRE, 100-person team, right? You kind of know the roles. Data teams, I give you a 100-person data team. How likely are we to predict like what the roles are and what they do, right? You have like data scientists doing data engineering work, data engineers creating dashboards. It's a whole, it's the Wild West out there.
Why do you think that is too? Like, what is it about data that leads to this kind of specialization?
That's a good question. I don't think there's any one factor. I would say maybe the biggest factor is just hype, right? Where everyone wanted to bring on a data scientist in like the mid to late 2010s and didn't have any data. So data scientists would have to do a lot of data engineering work, right? People today want to bring on more data engineers, almost like in reaction. And it's like, shoot, we need people to actually analyze the data, bring on the analytics engineers. So like the roles aren't very well defined. And I would argue most companies don't exactly know what they want out of the data team. They just kind of want to invest in data.
Yeah, I especially remember this in like the startup scene. We went through the startup accelerator in Toronto in like 2016, and this was really, like you say, when AI hype was really in, and like there were founders who were saying, yeah, so I have this investor who says he won't give me money unless we do this AI thing that like is only tangentially related to our product. And it's just like the classic kind of, this is what this leads to, because then you're forced to hire a data scientist or whatever to please it's kind of a bad mechanism. But do you see an analogy here though with software? Like, did this happen with software engineering in like, let's say the late 2000s?
I believe so. And I think one piece of evidence we can point towards is the rise of DevOps as a concept, but also as like a role, where there was kind of like this idea of like software engineers, but having to, deal with the deployment of data of software, not only the development, or like IT engineers who had to do a little bit of the development. It was very messy, the same way that we're describing things. But now there's like this beautiful fusion and harmony of the two, where you develop software with its implementation in mind, its deployment in mind, and kind of like vice versa. You fit the deployment to how the needs of the software. And now we have entire roles emerging from that, right? Like DevOps engineers and reliability engineers. I hope to see that happen in the data world. It's kind of uncanny how like one-to-one the analogies have been, right? Whether it's like version control, radical concept in the data world, right? You're just slinging SQL for a very long time. Now I have DBT, right? Which is just like modularized, version controlled, well orchestrated SQL.
And you would think of version control there as an example of, I guess, lineage, right? That's kind of the pillar it would most apply to, or?
It does, yeah, it does apply to lineage for sure. And also just to like the applying these transformations in a way they can trace back over time. Yeah, you're right. It is lineage.
Okay. No, I was trying to make sure I understand like where these things map, because you really you start to see. I think I recommend people read. I'll link to it, but there's one essay in particular where you break down these 4 pillars, and you're really explaining how they're orthogonal, like how each pillar really is a different kind of, not totally non-overlapping, but almost completely non-overlapping element of value that you're introducing to the paradigm. It's one of those things that's clarifying in retrospect. Like you kind of go, oh yeah, this is a thing. This is a thing that I should be monitoring my startup. I should be paying more attention to, in a way, actually, even for personal projects. Like one of the things that came across here was, I know this is mostly geared towards enterprise, but as I was reading this thing, I was like, oh damn, I've definitely done personal projects where I haven't paid attention to these principles, and I modify my data set and I can't remember, like what I didn't store the previous version or whatever the changes. So do you think these principles do apply to personal kind of or smaller scale projects, I should say, and how would you modify them in that context?
When the stakes are lower, you don't necessarily need to have all this. Exactly. Like if you're a professional physicist or like in grad school, like you do want to keep a detailed lab notebook. If you're just running a little experiment at home, right? It doesn't matter too much, but it's really I'd say it's really up to you. And the ideal world is if the decision is very easy, right? Like if you were to make a toy software project, I'm going to make a landing page, and I committed to GitHub, it's already there, right? The decision, I didn't have to make the decision, it's already there. Ideally, that's the case with data too.
Right. Yeah. No, that makes sense. I mean, obviously, yeah. Tune your expectations or your requirements to like the scope and size of the project and the stakes. So I guess we've talked somewhat about DevOps and data ops. And you mentioned that the analogies are really close. I think in a weird way, DevOps is, while it's new, it's also kind of accepted now. I think to some data scientists, it might be a bit of a foreign concept too, but I'd love to get a little bit of a sense from you how you contrast those two things, like DevOps and data ops. I know we've been touching on different aspects of it so far, but just to get it really clear so people have it in their heads.
DevOps, to kind of like trace back the history a bit, was this merger of software development and IT, what used to be called IT, but like how software was developed and then how it's deployed. And the kind of the combination of the two. And there's a lot of both best practices that came from this merger. Like for example, continuous integration is an example of how you develop software, is impacted by how you deploy it. Mm-hmm. And ideally, you do it in a continuous way where you can keep iterating on the software side too. And it also impacts the roles and the technologies. Ultimately, the goal is to help organizations deploy software more confidently, more robustly, and faster. Data ops, what we can learn from it in our world is data doesn't exist in the ether somewhere, and we're just like poking and prodding it, right? Like it's on bits in information, most of it in North Virginia and AWS, but like it does interact with the external world and is being used with the external world. And it's important for us to have the right tools and best practices to deliver data as a service and a product to our end users. And that the way that it's delivered and the way that we think about our work does impact the quality of the end product. And we're borrowing a lot from software engineering, right, with continuous integration, test-driven development, SLDC principles. But there are some like differences fundamentally where, unlike software, data has weight, right? Running a migration is not an easy thing, right? It's not like you can just like turn down this cluster, turn up that cluster. You have to like bring over 100 million rows. Good luck with that. Data also compounds, right? There's a time dependency of it. You can't like kind of reset a server. You have to like stop all the operations, backfill everything, and then you can turn it back on. And also data has a lineage, like we talked about, where right, this one piece of data has a history to it, right? This piece of data at the source has a future to it, right? We can't act like they're not related in any way. In the same way that in the software world, maybe you have this machine, this, API host that's hitting your database, and it's like, okay, that host went down. I'm just gonna shut it off and then start another one, right? Treating it like cattle.
Yeah.
Like you can't do that. And in that way, the data world is more complex. And while we can learn a lot, we have to be mindful that it's unique. I wouldn't say it's any like better or worse. It's just different.
Okay, well, that makes perfect sense. Closing on a more future-oriented note here. So, in the next year or so, let's say next year, 2 years, what do you think are some of the biggest problems that are likely to be solved, or that you're optimistic about solving in the data ops on the data ops side of things?
One thing that I'm optimistic about, unrelated to what we work on, is streaming, right? Being able to collect real-time data and transform data in real time. There's many exciting startups working in this space. And what is commonly the case, which is like batch work, where it's like, this data is refreshed every 15 minutes. It's just a subset of the real-time case. Of course, we're optimistic about observability. Like even if we didn't have a horse in the race, it's just like, okay, if we imagine the data people of 2042, right? They will be writing SQL, but I also hope that they have visibility into their data systems. It's actually a little bit absurd that today we don't. Like in the future, they'll be able to say, okay, this piece of data came from here. We
Right.
had 99.5% uptime, and these are some delayed tables, but the most important ones are correct. And I can make this migration with full confidence that I know the impact.
Yeah, it's when you lay it out like that, it's so clear that this is something that's desperately needed. If only, I mean, for the company to understand what it's doing right and wrong in terms of its even data collection practices. Like, if you're just reducing everything to one data set and the data set's a problem, the different parts of it come from different places, really hard to reason about it productively.
Totally, right. And you're just like kind of, without that information, you're kind of relying on your hunch or like what everyone else is doing, which is totally, I mean, those are totally valid, but we're data people. We can use data, right?
Well, I very much hope that this stuff comes to pass. It would be great. I mean, just again from the selfish AI kind of policy and AI technical safety side, this kind of stuff really seems like it's an important ingredient. Not to harp on that too much, because I know that's not immediately the point of your company, but I do think it's one of those happy coincidences that I think it's going to help with applications like that and a whole bunch of other things too. So thanks so much for joining me for this. I really enjoyed this chat. And can you share a link actually to any social stuff or any work that you'd like to share in connection to this?
Totally. Check out metaplane.dev. For our website, you can sign up, implement us in 10 minutes. We're on Twitter and LinkedIn at /metaplane. And I'm on everywhere as Kevin ZNGHU.
Awesome. Okay, so we'll place links to that throughout the blog post that'll come with the podcast. I'll also link to some of those blog posts that you've written on the topic of observability. I think, again, this is something that, whether or not you work in an enterprise company, just being aware of these principles, starting to think about it, you'll start to notice these patterns popping up in more and more places. So I think it's worth doing.
we live in a very exciting time where we can put these concepts on very solid footing and both help out ourselves, but help out, the next generations of data people, just, not have to deal with the problems that we've had to deal with.
Yeah, pay it forward and leave the data field better than you found it. Thanks so much, Kevin.
Exactly. Thanks a lot. Totally my pleasure.